All right, hey everybody. Welcome back. Get started here. Cool. Sweet. You guys can all hear me okay, hopefully. Sweet. Sorry, I cannot appear on a floating platform like Rihanna, but we'll try to keep it interesting. Okay, so a few announcements, lots of announcements. So we got homework 4 due Wednesday. We have project 1, our first project's out, so that's due next Friday, and then we have checkpoint due this Friday. So kind of like just make sure you're halfway through. And then a few things about the midterm. So we're 4 weeks away from the midterm now, basically. So it's coming up, and so we have the midterm on Friday, March 10th. We're going to release a midterm accommodations form today after lecture. So please submit this as soon as you can. Sometimes there's some issues with your schedule or whatever it is. We will try our best to accommodate. And so just make sure you let us know as soon as possible about this. And so this is due in also kind of like right after the project, but it'll be out today, so you can submit it today. And then you can always email us if there's like any other issues or concerns with the midterm, but we're usually pretty accommodating. And then my office hours are today after lecture in the afternoon at FSM as usual. So back to in person. Had to do it on Zoom last week, but I'll be here today. Cool. Any questions about any of that stuff? Good. On the Zoom, you guys can hear me on the Zoom? Okay. So today we're going to basically wrap up everything we've been doing with tables. We'll just recap some of the methods that we've learned. We introduced a few new ones on Friday, so we'll use those a bit today as well. And then what we're going to do after today's lecture is like start to switch gears a little bit towards some conceptual stuff. So we'll actually start analyzing some of these data sets, coming up with some interesting conclusions, thinking about how do we even arrive at conclusions, what kind of assumptions can you make about the data. So that's kind of what we'll start to transition to towards the end of the week. And then pretty much like the rest of the semester will be a lot more conceptual focused and not so much, I mean, we'll start using Python throughout the entire semester, but there won't be too many new concepts that you'll have to learn in Python after this week, I would say. So today we're just wrapping up tables, which is what we need to analyze interesting stuff. So we've covered a lot of important methods so far. So firstly, we started out with select and drop. So this is how you can take your table and just like only look at certain columns. You can either like remove columns or just select certain columns. So that's what those are for. And then if you want to do the same thing with your rows, then you use take and exclude. So you can like take some rows or exclude some rows. So analogous thing, but for rows. And then one really useful thing is you can arrange the way that your rows are displayed using the sort function. So this lets you sort by a specific column. So your entire table gets sorted, but it's with respect to the ordering in one particular column. And then where is what lets you filter specific rows based on criteria in a column. And that's the one we're going to be using a lot. Then we learned apply, so you can take a function and actually like run it on every single individual in your data set all at once. And it's a really efficient way to do that. And so generally you're going to apply your function to some columns, one or more columns, and do something interesting with the data in the columns. And then last week we learned group, which is how you can take your rows and then like combine them together. So you can take like different sets of rows and like group them together based on like certain criteria. So we'll do some more examples of that today. And then you can group based on just a single column, or you can group on multiple columns. If you group on multiple columns, then you're looking at like combinations of unique values between two columns, versus if you just group by one column, it's just like unique values of a single column. And then the last couple of things we covered towards the end of last week was pivot. So this is just another way to rearrange your data. It's pretty similar to doing a group with two columns, but it lets you see all the data in this like bigger table rather than having to like scroll a bunch all the way down. And then the most recent thing we learned is join. So we'll see some examples of this. This is very useful when you have data in like two different tables. So you might have like some partial data in one table, and then that same data is talked about in another table, maybe referenced in a different way or with different terminology. You can combine them together, and we'll see an example of that today as well. Cool. And then if you have more questions on like how all these work, we have this really nice reference sheet on the website. So just go ahead and click this so we can see this. And so this explains kind of like all of the different methods that we're going to be using in this course. And it goes into lots of detail on every single one. So for example, like table.num rows, we can see like what does it actually do? What are the arguments? In this case, this one doesn't have any arguments. And then what is the output? So in this case, the output's an integer, the number of rows in the table. So this is a really helpful way to look at some of these. So for example, we have like the drop function here, the where function, take, and so on. So this is just a helpful kind of sheet for you to look through. And it's not that you need to like memorize this page or anything, but it's just helpful for you to kind of just make sure you understand like what this function is doing. Maybe you could make like flashcards out of these or something, but I think it's just a good way to understand what the functions are doing. That's really what's going to be most important, especially in like an exam scenario. And we will give you a reference sheet of like all the function names that you need to use on the exam. So, you know, you don't have to like memorize all the names, but like you should know what they do and like know when to use them. That's like the most important thing. So we'll try to combine everything together today into a single example and use them all together. Cool. So the main focus for today's lecture is going to be a single data set, actually. So this is going to be about bike sharing. So back in the day, before we had like scooters and all this stuff all around campus or all around the city, we did a pilot in the Bay Area to try out bike sharing and like see what the usage is, what's the adoption like. And so this was a few years ago. And this was a pilot that was done in some specific parts of the Bay Area. So it wasn't done in East Bay, but it was done in like San Francisco and sort of the peninsula all the way down to San Jose, actually. And so the Metropolitan Transportation Commission organized this really interesting open data challenge where they basically made all this data public. So they went and did the pilot. They had a bunch of people do a bunch of bike sharing for like several months, let's say. And then they exposed all that data publicly in this competition where people could like visualize the data in interesting ways. And so this is an example of like one of the visualizations that someone made. It's kind of showing like all the different stations where you could pick up and drop off your bikes, and it's visualizing them based on the time of day. So in this one, it's showing like the stations that were the most popular during the morning commutes. In this case, it's showing what's happening during the lunch break. And then this is the evening commute. And then a few other times, such as like in the evening time, the night time, the hotspots are like a little bit different. So there's just like different interesting ways to visualize this data and like present some findings. So we'll go through that process a little bit today as well. And then we'll try to use these table methods to find some interesting discoveries about this data set. So we can go ahead here and look at the actual data here. And so this is just being read from a spreadsheet called trip.csv. And then we have every row here is going to be a trip. So this is like a trip that you took on the bike. And so there's like a unique identifier for the trip, the duration, which is going to be in seconds. And then we have the start date of the trip, the station where you began the trip, start terminal, which is like, I guess, another identifier potentially for the starting point. And then we have like when the trip ended. So, I mean, you'd expect most of these trips to be like on the same day, but sometimes it may not be. And then we have kind of the end station where they stopped, the actual number of the bike that was taken on the trip. And then we have something called subscriber type. So this one's kind of interesting. Basically, you could pay per trip, but you could also subscribe and then have any trip under 30 minutes be free. So a lot of people ended up doing that. Most of the people who actually did this pilot ended up just being subscribers because for the most part, they were just doing like short trips. And so it was more economical for them to just get the subscription. And then you can just do like a bunch of 30-minute trips for free. And then we have like the zip code of, I guess this would be maybe where it started. I'm not sure. This number seems a little bit weird, but anyways, that's what the data we have. And so one thing that could be interesting to look at least in terms of numerical data, one of the most interesting things here is just the duration of the trips. This is kind of cool to see like how that changes, how that varies, you know, what kinds of trips are people taking? You know, are they really like going beyond that 30 minutes? How often? So we can try to visualize this really quickly by just doing a histogram. So we can do trip.hist and then pass in duration. And then let's see what we get. So we see something like this. And it goes all the way up to, what is that, like 17,500,000 seconds, 500,000 seconds. So any guesses what's going on here? Why is the histogram looking like this? Yeah. Yeah, maybe there's an outlier going up to 17 million, like, you know, what's going on there? So let's try to see maybe what's going on. Let's actually look into the data. So one nice way to maybe take a look at some potential outliers is to just sort the data by the duration. So let's just take our table trip and then we'll sort it by duration. And then let's make sure we're doing descending equals true because we want to look at the largest values first. So I'll go ahead and run this. And so here's what we see. So we see a duration up here at indeed 17 million. Then we see another one at like 2 million seconds and so on. So it's kind of interesting. Let's look at the start date and end date of this one. So started in 2014 and then ended in 2015. So this was like a year-long trip. So any guesses what happened here? How is this possible? Any thoughts? Yeah. What's that? They forgot to turn it in. Yeah, that seems like a long time to forget to turn it in, but possibly. In this case, probably what happened is it actually got stolen, and then it was like recovered at some point, right? So it's kind of interesting, but you can see this in the data here. So this is definitely influencing the results of the histogram. Probably most trips are not going to be like this, so we might want to maybe cut out some of the data. And then actually, before I even do that, it's good to also just look at how many rows we have, first of all. So we have a lot of trips. Whoa, sorry. We have a lot of trips here. So we have over like 300,000 trips here. And so this is just with everybody. So maybe what we can do is let's try to look at just the trips where the duration is under, let's say like 30 minutes, because that's like the free ride length. So we can just try that. And so let's just call these commutes instead of trips. And so we'll say commute equals trip dot where duration. And then we want to do r dot below 30 minutes. So this is in seconds. So we could just take the number of seconds and multiply that by 30. And that will give us the actual number of seconds that we want. And then we'll do a histogram of just that. So we'll do histogram duration after we've done that. So again, data is in seconds. So we have to convert it into like 30 minutes. This is how we would do that. So 60 times 30, that's how many seconds are in 30 minutes. And then we can go ahead and do histogram this. So now we see something like a little bit more interesting here. And then kind of these numbers may not make that much sense here because it's like in seconds, but a simple way to think about it is like 6,000 seconds is going to be like 10 minutes. 12,000 is going to be about 20 minutes. And then 18,000 is going to be 30 minutes. And so you can see here kind of looks like most of the rides are, you know, between, or certainly like less than 20 minutes, it seems like 12,000 or 1,200, sorry, is like kind of our level for 20-minute rides. So most of them are there. And even though they have this like 30-minute limit, most people aren't really getting that close up to the limit. And then another interesting thing here is there's a gap here at 0. So there's like nothing after 0, which is interesting. And so the reason for that is because in this particular pilot, the minimum ride time was 60 seconds. So even if you just like take it out and like, oh, oops, I need to actually put it back, it's going to count as at least 60 seconds. So that's why we always see like something greater than 60 seconds. And I think something that might be helpful is to look at this in terms of like bins. So let's actually specify some bins rather than just letting like Python pick it. So we'll just do bins that are like in a range from 0 to 1800, and then let's just like increments of 250 seconds. And then let's also just put units so we can actually see what's going on a little bit clearly. I made a mistake. So bins, I believe. Okay. Cool. So now we have it in terms of bins here, and we can see sort of what's going on within any particular window here. So one kind of interesting question might be to ask is, you know, what percent of this data has trips between this duration, so like 250 to 500. So maybe this is a good question to discuss with the person next to you. So take a look at this visualization and see if you can just approximate this. You don't have to get this like perfectly right, but just see if based on this histogram, can you kind of approximate what percent of the trips are between 250 to 500? Take like a minute to discuss, and then we can go over the answer. All right, so let's see. What'd you come up with? How did you come up with an answer? Don't just say the answer, I guess. Curious, what was the thinking? Yeah. So you looked at the height of the bin 0.15, and then, well, we need one more step though. So if we have just the height, that's kind of like the density, the crowdedness, but we want to know like the area. So like what percent of the data, because remember area is percent for histograms. So we have the height, that's great. So we have 0.15 is the height. What else can we do from there? Yeah, so to do area, we have to do width times height, right? And so the width of this is going to be 500 minus 250. So I can just write this out. So the width is 500 minus 250, and then we have to multiply this by the height. So the height's like roughly 0.15. It's not exactly, but it's pretty close. And so we can just go ahead and do this, and we get 37.5. So this is a decent approximation that like 37.5% of the data is lying in that interval. Okay, and so again, it's because area is percent for histograms. Now, this is just an approximation. We could actually calculate the exact value if we wanted to. And before I even do that, any thoughts, like, do you think the exact value, the exact percentage is going to be more or less than our approximation? How many people think it's going to be more than the approximation? How many people think it's going to be less? And why do you think it's more, the folks who said? Yeah. Yeah. Yeah, so if you look closely at the bin, the bar is like slightly above 0.15. I don't know if you can see this. Okay, it's a little hard to see, but let me try to zoom in. So you can kind of see there's a few pixels here above the 0.15. So we know like basically this bar is gonna be a little bit bigger than 0.15, actually, the actual height. We know the width is definitely 250 because that's the width here, that's exact, but we just don't know about the height. So it's gonna be a little bit bigger. So that's what we should expect to see. And then the way we could actually calculate this is in a couple steps. One is we could say, okay, let's get the number of rows that have a duration between 250 and 500. So we can use the where function to do this. So we could do commute.where duration r.between 250, 500. So that's going to get all the rows where the trips are between in that interval. And then we can just do .num rows. And so that will tell us how many people there are. So there's 129,000 trips that have that duration. And then once we have that, we can just take this and divide by the number of rows in the entire table. So commute.num rows. Whoops. And so this is basically taking number of trips that were between 250 and 500, divide by the number of all trips, and that should give us the percentage that's in that interval. And so in this case, we get 0.3. Let's multiply it by 100, actually. So we get 38.15. So pretty close to 37.5, just a little bit off. So it's a little bit higher as we expected. Yeah. Oh, for the R between, do you have to do 250 to 500? I believe it goes up to, but not including 500, but I'm not totally sure. Yes? Okay, nice. So it does go up to, but not including 500. So it's defined the same way that we've been defining bins as well. So when you see this bin, it's up to, but not including 500 as well, just like the way we introduced it. Yeah, so you can kind of, they're working together the same way. Yeah, good question. Cool. Another interesting thing we can do, a little bit surprising actually. So this is what the histogram looks like when we use those bigger bins. Another thing we can do is just specify the number of bins. And so let's put like a bunch of bins on this. So we can put 60 bins on this, and we see something like this. So this is kind of cool. It's like really nice and smooth, and it has this like interesting pattern. And so, you know, this has like, I heard somebody say this has a skew. So this is good to understand, like, is this skewed right or left, right? And so we have like this like tail going out to the right. So it's kind of interesting. And yeah, it's cool that even with that many bins, it's still like so similar. It's like very predictable almost. You can kind of very reasonably understand like what type of rides are being done here. And we've kind of removed the outliers as well. So it's just kind of, you get this really nice pattern. It almost looks like I could like fit a curve to this, which is kind of interesting. So anyways, that's trip durations. Another interesting thing we can look at is some of the categorical data in here. So not only do we have durations, but we have all this information about stations. It might be interesting to see like where are people taking the most rides from. And so one way we could do that is we could maybe sort by the count. And before we can sort by the count, we actually need to group maybe. So let's take commute, let's group by start station. And so what this is going to do is it's going to take our entire table and then just find the unique values of start station. And then it's going to show us the count of like how many trips there were for each unique start station. And then once we have that, maybe we could sort that by count. And then we could see the ones that have the highest counts. So descending equals true. So this is one way we could find the starts. So any guesses here? What do you think is going to be the station? Let's say if you're familiar with SF, like the station that's going to have the most starting commutes or starting trips. Like most trips have begun from this station. Any guesses? If you're familiar. Yeah, in the back. Yeah, the Caltrain station, right? Any other guesses? Yeah. The ferry building, yep. Yeah, that's another good one. Let's see what it is. Taking some time to run. Oh, it's taking a lot of time to run. Okay. All right, so we have Caltrain station is in fact the first one. And then it was so popular, they made a Caltrain station 2. So it's just like getting flooded. And then we had the ferry building. So yeah, good calls there. And then we have a few other ones here. So some of these may look familiar, some may not. Yeah, the Caltrain one makes a lot of sense because you have a lot of people kind of coming in, especially maybe like from South Bay. They're taking the train up to work and then they hop off the train and then now they're going to go bike. So that's a really high population area. So yeah, so it's kind of cool. And so just recapping the steps here, basically when you did group, it shows you just the unique values and then we sorted by the count that allows us to sort by the unique ones that like showing up the most often again and again. Okay. Now what if we wanted to see like the number of trips that were taken between like any two stations? What's something we could use to do that? If you want to just look at the number of trips between any two stations rather than just like number of trips from a particular station. Yeah. Yeah, so we could try group, right? That's one thing we could do. So we could say, let's do commute.group. And then we could pass in, for example, like start station and end station. And so this is also taking some time to run. But this is what this is going to do is it's going to say, let's find all the unique combinations of start station and end station, and then like how many trips were in that unique combination of the two. And so that's what we get here. And so you can see like second and Folsom, and then you have like all the other stations that you could have gone to from there and the number of trips that went there. Now this is like really might be hard to navigate because it's like 1600 rows here. So is there another way to do this maybe that would be a little bit easier way potentially to see all this data? There's combinations of like starts and ends. Yeah. Yeah, we could do a pivot. So that's another way. So we can visualize the exact same data, but we can use pivot. And then the way we call pivots a little bit different. So we put these as two different arguments. Whoops. Start station and end station, sorry. And we can look at the exact same data, but it's going to be in a pivot table form. So slightly different. And so like you're going to have all the unique start stations across the top, all the unique end stations on the left here going down, and then we have all the combinations of things here. So interesting when you look at it this way, you can right away see like a bunch of zeros here. Any guesses, why are we seeing zeros? Why are there like 0 trips between certain combinations of stations? This was a Bay Area pilot after all, so what's going on? Yeah. Yeah, there are no trips between the stations. But why is that though? Because we did a pilot in the Bay Area, so we would have expected like kind of people going from all these different places. Yeah, so we filtered by under 30 minutes at a couple lines above. And so because you've done that, some of these stations may just not be, it's like not physically possible to like get there in 30 minutes. Like maybe you could get there over a longer period of time. But for example, you have SAP Center, which is like down in San Jose, and then you have like, Caltrain station. So, it's like not really going to be possible to make that trip up in 30 minutes. Like it takes like an hour drive at like 60 miles an hour. So you're probably not gonna be able to bike it in under 30 minutes. So that's why we're seeing that. So it's kind of interesting. So you can see like zeros really right away, and that's kind of why. And then you can also see some places that have like lots of trips. So for example, this one, you have Broadway at Battery has like 1,000 trips to Beale at Market. So that's kind of interesting. So you can see like maybe those are the ones that are a little bit closer together and like very common that people are taking those trips or something. So you can see all that really, really easily. Now, what if instead of just counting up the number of trips in every combination of stations, what if we want to look at like the duration? So we want to see combinations of stations, but maybe the average duration of the trips or something. How could we do that? Any guesses? With our existing functions that we have so far, what could we do? Yeah, so we can do np.average, but we have to like specify that we want the average of the duration. So there's like one extra argument there, but that's pretty much the answer there. So with pivot, what we do is we can say, okay, now I don't want to just return the counts. I want to actually return the durations. So I specify values as durations rather than just being counts. And then what do I want to do with those durations? I want to take the average of them. So how do I want to collect them is the name of the argument. And we do np.average. And so when you do it like this, what's going to happen, and I'll do this on a new line actually. So what's going to happen is all the counts get replaced with the durations and specifically the average durations. So we're going to run this, and then every single cell here will now have an average duration in it, if there is a valid average duration. So now we can see, for example, second and Folsom to fifth at Howard, average trip time is like 418 seconds. So we can see that now. And so it just got replaced. And so the reason that we need to specify average, well, one was because I asked you guys how do we get the average, but in general, when you're doing a pivot like this, you need to tell it, if you're going to display another value rather than a count, which is going to have to be like a value in like a third column, Python needs to know like, okay, you want me to put a bunch of durations in this single cell? Like that doesn't make sense. I need to somehow combine all those durations into something. And so np.average is the specific way we're going to combine it in this case. But we could combine it in like any other way, basically. So it's like whatever function that could run on a column and like combine everything to one value, you can pass in over here in the collect. So for example, instead of the average, what if we wanted like maybe the average is going to be skewed by like outliers, because we already saw this happen once before. So what if we wanted to look at sort of like the time it should take to get there? Like, I don't want to worry about like somebody who started this station and went and like got some food somewhere and like took their sweet time and then they got to this end station. Like, I want to know if I'm trying to go like direct and like not worrying about stopping, like what's the amount of time it's going to take to get between any two stations? Any guesses on like a different way to collect that data, that duration data, instead of the average? Yeah, you had something? The median? Yeah, so the median's one thing we could try, right? But what if we know it's like it's SF, like a lot of people are like stopping for stuff, and you know, we want to know like best case scenario, like how long is it going to take me to get from one station to another? Yeah, take the minimum. So that's one thing we could do, right? So it's a little aggressive. You might be getting people who went like really, really fast, but this is kind of like the best case scenario. You have like no red lights, like you're able to get through everything, assuming you pay attention to red lights. And so we can do this with minimum. And so this is just another way to collect all of those values together. So basically, this is saying like, okay, give me all the unique combinations of start station and end station. Once I have that combination, each combination is going to have a lot of different trips that associate with that combination, right? And so it's saying, okay, get the durations of all those trips and then combine them. How? Take the minimum of them. And so in this case, we're just seeing the minimum trip time. So we're seeing that, for example, second to Folsom and fifth at Howard at the minimum takes 268 seconds. Whereas if you go up here to the average, it was like 418. So the average is about twice as much. Cool. Yeah, you had a question? Yeah, so can you display two values in each cell, like maybe show the minimum time and the average time? So, I mean, with the current, it's kind of limited here. It's probably beyond the scope of the class. There might be a way to hack it, but like in general, you won't really be able to do that. It's just going to let you do one value. So you'd have to just do like one on each. I don't think there's a way to like show it nicely and like, you know, two of them together, like comma separated or something. So yeah, unfortunately, you kind of have to go back and forth to look at that. That would be cool though, maybe something to add. Yeah. Sorry, just a little louder. Oh, could you take like two tables with like the min and the max, and then what do you want to do? Like combine them together somehow? Maybe there could be a way. I think like the issue is you're going to have just like a bunch of extra columns probably. So you could have like columns for the mins and then columns for the maxes. You could put that into like one really big table, and you might be able to like rearrange that by like alphabetically or something, so they're like next to each other. So you have like min and max, min and max. That's like, yeah, that's interesting. That could be one way to do it. It may not be that clean, but seems like you could probably try to find a way. Yeah. Yeah, so yeah, you're kind of getting to the answer I was trying not to share, but you could create a custom function that will return the min and the max together as maybe like a string or something. So you could like format it nicely. We could maybe try it. I mean, if we have time, we'll go back to it and try it. But this can actually be any function. So you could make your own user-defined function and like do whatever you wanted in it. So for example, I could make something like min and max. All right, I'm just gonna go ahead and try it at this point. And then we could say like return the string of the minimum of the values plus comma. I don't know if this is going to work, but let's just try it. The maximum of the values. So I made this like very interesting function. And then basically what this does is it says, okay, if I have an array of data, take the minimum of the values and then give me the comma, add a comma, and then the maximum values, and then make that all a string. And so we could try it. This will be pretty cool if it works. I don't know if it's going to work though. Let's see. Let's see. I haven't tried collect with like string. I feel like it's usually numbers, but I don't see why. Oh, wow. Okay. That's cool. Nice. Okay. So you can see the min and the max together. So we kind of hacked it together. So this is kind of cool. I mean, in general, this is actually very useful because like you might want to make a function that's like collecting your data in like an interesting way. Like I don't want to just do the min. I don't want to just do the max. I want to do something more interesting. And so in this case, we were able to do that. And so you could imagine you could do more interesting stuff. You could like add two different values together and like collect it that way. Sometimes it's useful to just return like the first value in the array. You could do that too. So you could just make like a function to do this. But you can basically put any function that will actually like, that can run on an array. Like if you can pass an array into that function and it can give back like a single value, then you're good to use that as like the collect argument for this function. Okay. Yeah. Yeah, that's a good question. How can you have values for the same start and end one, right? So for example, second and Folsom and second and Folsom. So the 61 probably makes sense because the minimum time is going to be 60 seconds. So if I like take out the bike and I realize like, oh, actually I don't want it, I have to put it back, I'm already going to get like charged for like 60 seconds. So that's why you have that minimum. The maximum, that's a lot. I mean, 1800, we talked about that. That's like almost at 30 minutes there. So maybe they like left that station, they went like biking around the city or something, and they came back, put it there. So something like that. Yeah. Yeah, good question though. That's good to observe. Sweet. Okay, we'll move on. That was interesting though. Thanks for bringing that up. That's actually a good one to like review, I would say, because that's a little bit beyond the scope of the class, but like not quite. Cool. So another thing we can try to do is maybe find like the fastest trip between any pair of stations. We kind of already did that actually with the min, so maybe we'll just skip this part actually. Let's do it in a more interesting discussion question. All right. So let's say, and I'll just type this out for you. So this is Civic Center BART. And actually, you don't have to like, actually type this code out. I'm just curious to see like the thought process. Like, are you going to do a where first and then a pivot, or what are you going to do? So discussion question for you is find the 5 stations closest to Civic Center BART based on minimum trip time. So like we define closest as like minimum trip time. So discuss with the person next to you, think about how could you maybe answer this question, and return a table that has just those 5 stations that are the closest. Okay, so let's try to maybe do this one. Any thoughts? Like, what's like the first function you might use here? Any guesses? Anyone else? I'll give you a chance too, don't worry. Yeah. Yeah, maybe we could start with the where method, right? Because it's saying you want the stations that are the closest to Civic Center BART. So I need to probably do something like where the trip involves Civic Center BART. Like we got to start there somewhere. So let's do that maybe. So let's say like we're going to take all the stations where, in this case, let's just do like start station, I guess. So we'll do where start station is Civic Center BART. And actually, I don't know if that's actually going to work. So let's actually just try this out. Stations is not defined. What? Did I not make this? Huh. Wait. Oh, sorry. It should be shortest. Oh, sorry. I guess I skipped some code. No, this is why you should always do what you write down. Okay, hold on. Figure this out. Okay, so I guess what I was going to do, but I skipped for you guys, was shortest is duration dot group, start station, end station, and then group by min. Oh, seriously? Okay, I guess I had another line that I forgot. Okay. Start station, end station, duration. Okay, now this should work. Cool. All right, so we have, this should be shortest dot where start station civic center BART. Okay, so that's not working. So maybe let's try r dot containing. Maybe I just spelled it wrong or something. Well, actually that shouldn't really matter, but let's try this now. Okay, so maybe it's not exactly civic center BART, maybe it has like some other stuff in there. Oh, okay, that's why. Okay, cool. So r dot containing, we'll go with that because I guess maybe there's like multiple civic center BART stations. And so these are now like the trips that started from there, so that's great. And then we said we wanted the 5 closest by minimum trip time. So we have all the ones that started from here. We have like all of their durations. So the next thing we want to do is try to actually maybe sort by the duration. So in this case, we have a table that has duration min because this was created from the group function up here. Actually, maybe this is worth showing you as well what this has. So shortest, in this case, we did group by start station and end station, and then do the minimum of the duration. Because in this case, we just selected duration as like our last column. So when you do a group with 2 columns and then just specify like the function to collect, it's going to collect everything else in the table. In this case, this table just has these 3 columns. So we have the duration mins already here. And so here what we can do is just sort by the duration min. And so this will by default already be sorted in a way that the largest ones are at the bottom and the shortest ones are at the top. So now we have this. And at this point, we just need to like take the first 5 ones. Now we probably don't want to take this one because it's like the same one, civic center to civic center BART. So that's not as interesting. So you might want to just take like a range from like 1 to 6 or something like that. And so that's how we could do it. So we could say maybe, let's say these are from civic center. And then what we can do is from civic center dot take np dot range. And then we can go from like 1 to 6 rather than including 0. And then we'll get the actual stations here. And if you wanted to go further, you could go like actually select the column and station. And that actually will get you like the actual stations itself. So there's like a few steps there. But that's how we can kind of answer that question. So these are the closest stations in terms of like the minimum possible duration from civic center BART, starting from civic center BART. And so we chose start station as civic center BART. You could do end station as well. If you think there's a reason that it might be like different one way or the other, but in general, like these trips should be like kind of the same. Doesn't really matter whether you're starting there or ending there. It's all about like trips involving that. So cool. All right, so last couple things wanted to show you. One is we can actually make some visualizations of maps inside Python, which is kind of cool. So we're going to take in another table. This is going to be called station.csv. And I'm just going to drop a couple columns that I don't want. And so you can just see what this has. So in this case, this has a list of all the different stations and has the name of the stations as well as their coordinates. So like latitude and longitude. And there's like this other column called landmark. But basically, if you have this information as like latitude and longitude, you can actually make it, plot this on a map in Python, which is kind of cool. And so, for example, let's say we wanted to look at just the San Francisco stations. We could do this and make a map of just those. And so what we're going to do is, actually, to save a little bit of time, I'm just going to cheat a little bit and copy the code here. Oops. So I'll copy this code and explain it. So we'll start out first by taking all the stations where the landmark is equal to San Francisco. So that's going to give us just the SF stops. Then what we're going to do is, Python's a little bit particular, especially the data science library. We have to like put everything together in a specific way. So we're going to take just the San Francisco stations and just select lat, long, and the name of the station. And then what we're going to do is relabel the name column to labels. And so it's going to convert the data into something like this. So we have lat as the first column, long as the second column, and then labels is like basically the name of the station. And the reason we have to do this is because there's a function in the data science module that lets us do something like this. So we can do map table and just pass in this data. And this function like requires our table to have this like order of stuff, lat, long, and labels. But we can go ahead and do this, and then we can actually see like these on the map. So it's kind of cool. And so for a little bit of reference, we're over here. Whoops. We're all the way up here. All right. So this is kind of a little bit of reference of these stations here. And so you can like see these on the map. You can like zoom in. You can click on an individual one. It'll tell you like the name of the station. And so this is like the Caltrain station over here. Okay, so that's like one kind of interesting thing you can do. And then you could also visualize this in a different way. So instead of like dropping pins, you can actually just show like some circles. So we can do that as well. So that's kind of interesting. Just another way to visualize some spatial data. And we won't have time to do this today, but you can actually even like add colors. So you could say like all the stations that are closest to like Civic Center, like color them by like how close they are. You can do that too, which is like another interesting way to like convey information. But we won't do that. So I guess one example that'd be worth doing is a join example, because we haven't done that yet. So we have two tables now, which is interesting. So we have this table, which has these like GPS coordinates and the names of the stations. And then we have another table up here, which has like stations like starting and ending and like the actual trips. And so maybe there's something you want to do, like combine this information. Like maybe we want to look at like something based on duration, but then we want to like plot things based on duration. And we can't plot unless we have like the latitude and longitude. And so this is a situation where we might need to combine things together using the join function. And so let's actually try to do this. So we'll go through an example. We won't have to discuss it because it's a little bit challenging, but we'll just go through it. So what we're going to try to do is we're going to map all stations that are within 4 minutes in terms of minimum ride time from Civic Center. So we already have the minimum ride times from Civic Center in this thing. So this is like Civic Center and like all the possible stations and like all their minimum durations. So we already have this, but we want to find just the ones that are within 4 minutes. So we can do a where here to, filter this down a bit. So we could do .where, duration min, r dot below. And if you want to do 4 minutes, that's just 60 seconds times 4. And so this is going to be kind of like the really close ones. So we'll call these like close to Civic Center. And then once we have that data, we can just take a look at it actually. So these are just the ones that are within 4 minutes. So it's actually not that many. And then once we have those ones, we can say, okay, let's actually try to combine this information with that geospatial data, that location and latitude and longitude. And so what we can do is do a join. So we already have all of the GPS coordinates in SF stations map data. So these are the two tables we're going to try to combine here. So this table has like a bunch of stations. We don't need all of them, but it has all the possible stations and like all their locations. So what we want to do is we want to take this table, take the end stations, look them up in the other table and just grab the coordinates. That's like what we're trying to do here, because these are like the stations we care about. These are like the closest ones. And so how can we do that? How can we take like just these stations, look them up in this other table and like grab the latitude and longitude coordinates of those corresponding stations? So the join function is what lets us do that. And so we want to visualize this at the end. So we want to keep this same sort of format where you have lat and long first. So we're going to start with this table and then join with the other table actually. And so here's how we're going to call it. So we're going to take this table, join, and then we say, what do we want to join on? So when you want to join on something, you want to say, what's the column that's like common to both tables? So in this case, the one that's common to both tables is this column, labels. So you want to join on labels. And then what do we want to join with? We want to join with this other table, close CC. And then finally, you have to specify, okay, so you're joining this other table. What's the corresponding column in the other table? In this case, it's going to be end station. That's the corresponding column. And so we'll kind of like combine those together. And so first of all, let's just take a look at what happens when you do this. So now what's happened here is we have labels from the original map data table. We have lat and long again. And then now we have some new ones. So we have the start station and the duration min, which got added as well. And so it's okay, we don't really care that much about these two for this use case, but what's happened is it's kind of like find the common elements between both of these tables. So it said like, let's find all the ones that are close to Civic Center and all the ones that have map data. And then let's find an intersection of those two. So like the ones that are close to Civic Center and have like map data. That's what we're seeing here. And so these are just like the closest ones. And then finally, if you want to actually visualize this, then we can go ahead and just select the columns we actually want for the visualization purposes, because Python wants us to do it this way. So we're just going to do it in the order that it wants. So lat, long, and labels. And then we'll go ahead and just call this like close markers. And then this is going to have just those columns selected. And so now we can go ahead and pass this into the function. So we can do marker dot maps table close markers. And so this will show just the ones that are close to. That seems kind of high. Wait. Oh, okay. I forgot to call this something. So let's just call this joined. And then only select it from the joined ones. There we go. So now we just have just those stations. And then now we have just the stations close to Civic Center. So we can visualize that here. All right, so that's an example of join. So any questions about join and how we combine them together? I'll show you the code again. Right here. So any questions on how we use join? Basically, the idea is like I have partial information in one table, partial information in another, and there's like two columns that are talking about the exact same thing. That's like the most important thing. So I'll just show you again the column that the table that we mapped on. So that's really the key here. So I have like two tables. This end station column is talking about the same thing as like the labels. Now it's not the same amount of data, that's okay, but they're talking about the same thing. And I just want to combine like all the other columns for the ones that match. And so I want to take like all these other columns and match them with these columns. And that's what we get here as a result, is the join column, join table here. Cool. All right, so I think we'll stop there. But that basically wraps it up for tables. And then we'll work on some new stuff on Wednesday. Hello.